this. For the first one, we'll see, did anyone solve it and get an answer?
Yes.
Kobe. Oh. The answer first. Okay. Did anyone get a different answer?
No.
Good, because that was the answer. Does anyone want to see this worked out?
No.
Okay. For the next one, let's work this one out.
What?
Thank you. Some of you may have got that one and it was fine, but some of you were struggling with this one. That's fine. First thing we need to do here is distribute the -3 to both of these on the inside. When we distribute this -3, think about that as -3 over 1. So that way when you multiply that and 5, 6, you're multiplying across -3 to 5, 1 to 6. Some of you may have did this without simplifying until later. Some of you may have simplified first. Either way works. I think when I did it, I simplified just because that's how my mind works. We have like terms on the right side we can combine, that 5 and that 6. And then even though it has these fractions, the problem is still the same. We're still trying to get our variables to one side, the constants to the other. I'm going to rewrite this over here. -7, 11. It does not matter what you started with. I'm going to move my 5/2 over to the left. And my 7 to the right. So here, I'm adding two fractions with the same denominator, which means I can combine them to get 6. The denominator wouldn't change, it would just be 6 over 2. You could simplify 6 over 2 to just be 30, and then divide. If you didn't simplify 15 over 6, you may have had, you should have still gotten the same thing, but it may have looked different.
And just another, the common denominator is the tricky part. I went 18ths. I went from 15 6 and 1/2. I made the 1/2 3 6. So I had the common denominator was 6. If you totally forget how to find the common denominator, you can always multiply the two denominators together. In other words, let's say you have the easy one to see. 1/2 plus 2/4. If you forget that 1/2 is 2/4, if you multiply 2 times 4, you get what? 8. So you got 8 as your common denominator. This is if you forget how to find a common denominator. You can always multiply the denominators together, and it's common. So 2/4 becomes how many 8s? How'd you get from 4? What did I do from 4 to 8? What did I multiply to get that? 2. So 2 times 2 is 4, how did I get from 2 to this 8 multiplied by what? 4, so 1 times 4. So 4 eighths, this is a common denominator, right? So you get 4 eighths plus 4 eighths. That's what you've got to have. That's probably what tricks some of you. You've got to figure out how to get a common denominator. And again, I think it's, if you forget that, like in this case, 5 halves, so she simplified 15/6 to 5 halves. She divided each. We took 3, divided the top by 3 and the bottom by 3, and that's to get 5 halves. But again, multiply when you're multiplying fractions. If you have, do you need a common denominator in this case? Those have to be common when you're multiplying. Yes or no for $2? You have to get a common denominator when you're multiplying.
No.
No, you do not. So this is 1/10. But this is, again, you guys have done this before, but you got to get, this is important. You got to have, when you're adding subtraction, common denominators, multiply and divide, you do not need a common denominator. It just makes it easy. Numerator times numerator, denominator times denominator. But adding subtraction, you've got to have a common denominator. And I think the easiest way, if you totally forget how to do it, multiply them together to get a common denominator. But we're going to have to get later, we're going to have to know how to find the lowest common denominator.
Yeah. We'll cross that bridge. For number 3, yeah, I think it's that marker. It's alright though. Andre solved this one already. The question asks, what does his work show about the type of solution? So what type of solution did he get at the end? No solution, because this is not a true statement. And really, I kind of answered that second part. How do you know? Because 2 does not equal 0. It never will. It's not a true statement. I'm not going to write all that, but that would be the answer to the second part.
That one should say, is it equal or not? You know, it says equal.
So basically,
really
all of these
the question should say, is it equal or not? So, because when you see an equal sign, you're trusting whoever made up the question, telling you the truth.
Did anyone find the value of K for this last one? So the wording and how it looks is like really confusing. We may need to finish this when we come back. So I'll start it and then we'll go from there. With this problem, I kind of understood what they were talking about. Somehow we need to find a value of K that at the end, this would give me infinitely many solutions. From what I know about infinitely many solutions, both sides have to be the same. So in my mind, I'm thinking, okay, how can I make this the same? So I start solving this. I go ahead and I distribute. And so far I see that they have similar parts, but still not exactly the same. Like I see the -2's are the same, but everything else not so much. So what I did was, I know that this part and this part should be the same. So I set them equal to one another. And you could actually solve for K, or you could think about it. If I need to get -8, what could I make K that when I multiply it by 1/2, I'm sorry, this was not negative. When I multiply it by 1/2, I could get -8. If you were actually solving it, to get rid of 1/2, I could multiply this side by 2, because these would cancel. I would also need to multiply this side by 2. So I could say that K is -16. I'm going to write this into the equation. I don't know what I'm trying to simplify it. If K is equal to negative 16. Negative 16 times 1/2 is negative 8. And now both sides look identical. They are the same. So from there, I know that this will now give me infinitely many solutions, but my k had to be negative 16. That was a little bit tricky, and you probably weren't thinking like that, and that's okay. I just wanted to see where your mind was for that one. Great. The bell's gonna ring in about 10 seconds. Right. For this problem, I know I kind of rushed that at the end. Just want to see if we had any questions, need clarification on anything on this one. You should have notes on your desk that look like this.
They do look like that.
Before we go through this, I did just want to ask if we had any questions on the delta math. It was the one that's supposed to be due today, the solving multi-step equations with variables on both sides. Did we have any difficulty with those? Want to see of those before we move on?
I was talking about the delta math thing, right? The one second.
The second.
Delta 16 is one.
Say that last part one more time.
And he's asked if we want to like see some
From the proportions or from the other type? Or both? From the proportions subcategory or from the other type or both? I don't remember what the categories were called exactly, but there was one where you were just solving the equations, and then there was one where there were proportions. I'm going to say proportions and other. So these are just one example from each type of delta math. This is just a random one I saw that someone got wrong. It may not be in this class. Negative or positive? It was negative. You can write these down, you don't have to. But this is just going back over the solving equations that we did last class. For this one, if I have two fractions that are set equal to one another, what is the first thing I need to do? Start solving it. Anytime we have fractions set equal to one another, how do we start solving it? The last one. If that was possible on the same side, then yes. In this case, that's not. I heard it, but don't know who it came from. The numerator to the denominator and vice versa. So it doesn't matter the order in which I write this. I'm going to put 7 times x minus 1 first. and then equals 5 times x minus 5. But they could be switched. And then from there, we could start solving this, distribute. Here I can kind of look at this and see I have two different coefficients. So this is going to give me one solution. And then I can continue solving this, pick one of your variables, move it to the other side, pick one of your constants, move it to the other side. I'm going to go this way, so subtract 5x on both sides, and add 7 to get 2x and negative 18. And then divide on both sides. So if you were having difficulty with some of the proportions, remember that first step is cross multiply, distribute. You usually don't have like terms after you do that. But then move one of your terms, move the other term, or you can do them at the same time. And then multiply or divide, depending on what that last thing is. For the other one, this is basically at this step, so I don't need to cross multiply or distribute. I just need to move terms to the other sides. So I'm going to add 4x, and you could have done it another way, and subtract 9. So this would give me positive 2x and 18. I did not purposely choose that so that we would get similar answers, that just happened to work out that way. Weird. If you did not do that delta math, you still can. Go back, try it, do it. Remember that that's informative, and I just write it down on my folder to see who's doing it and what scores you're getting. Questions on those? Okay. So the last piece of notes we're going to talk about in this unit is solving literal equations. You should have seen this before, so it should be reviewed, but if it's not, that's okay too. It kind of answers some of these questions too on your notes. But if I ask you, what's the difference between it's raining cats and dogs and it's literally raining cats and dogs? Then awesome.
It's raining cats and dogs can be taken as instruction, but it's raining cats and dogs can be taken as universal sign and cats and dogs is called the sky.
So one is like actually occurring, one is an exaggeration. This would be another example. When people say I got your back, they don't literally mean they took your spine out of your cell. So exaggeration, literally, and then this is a literal. So literal in general means actually or an exaggeration, but when we talk about a literal equation, it's kind of different. So a literal equation is some sort of equation that we would solve just like normal, like a regular equation, except we're not going to get an actual answer. We're literally solving it like normal, but we don't actually get an answer. So if I were to solve this for x or solve it for y, well, this one's simple enough that I can figure out what the number is. But I won't ever know the actual value for the variable. And that's the part that's like kind of confusing because you expect to get a value and you won't. So go ahead and flip the page to this one. That's it. I'm going to choose out and talk and raise it. I'm going to do that. Okay. Okay, so a lot of these are ways to solve equations. You know or should know most of those. They're there if you need them. Some of them, like the think backwards, is what do I need to do to get this by itself? Just keep that part in mind. Some of these equations are going to be regular equations where we solve and get a number. Those aren't the literal equations. Then we're going to do some that we are just solving for some variable and we won't have a value for it. Those are the literal equations. We're going to go through some of those. So for example 1, if I were to solve 2x equals 10 for x, how would I get x by itself? Divide what? Both sides by 2, and I would get 5. I can put that back in. 5 times 2 is 10. That works. Now, if I was trying to do the same thing in this example 2, but now I'm solving for h. I don't know what g or h or m are, but I'm trying to solve that equation for h. How would I do that? Yeah, so it's going to be the same even though it's just variables. These g's end up canceling each other out, and I'm left with just h equals m over g.
Think of the solvent for like it's got to be a loan. One is the loan. Actually, what the variable is the loan, whatever you're solving for. It needs to work. So you want it to be by itself alone. So that's what, if you look at all of it, solve for h. I want h by itself. I want x by itself.
That's good though, it'll help you remember it. So I don't know what h or m or g their values are, but that doesn't matter because all it asked was to find or to solve this for h, and that's what we did. When you are checking literal equations, there is a way to check them. Sometimes it gets messy the more variables you have and the bigger the equation is. I will do that here in a second. I would definitely recommend checking it to make sure it works. You can't check literal equations in Desmos though. That's the only downfall. So I'm gonna put this back into my original equation where h is. So that would be g times m over g equals m. If I were checking this, if it was a regular equation, when I put the number back in, it needs to be number equals number. When I check it for literal equations, whatever it equals needs to be the same variable. So at the end, it should be m equals n. That's how I know it works. So here, when I multiply g times m over g, this is really g over 1. This would become gm over g. Cancel. Leaving this m equals m. So that works. Do you have any questions on that example 2 before we move on? We're going to go to example 3 now, which is just a regular equation, so we're going to get a number. How would I solve this for x? Subtract 5 on both sides. And divide both by 2. I can put 3 back in. 2 times 3 is 6. 6 plus 5 is 11. That works. But now in example 4, when we have something similar, but they're all variables, the process is going to be the same. It just looks different. So how would I solve this for x? Subtract b. When I subtract b, it just goes over there. I can't combine these because they're not like terms. So I'm going to have ax equals c minus b. And then what? Divide everything by a. These a's are going to cancel, and I'm left with this x equals c minus b all over a. Again, I have no idea what x, c, b, a, what those values are, but I don't need to know that. I am going to put this back in so we can check it. So I'm going to put this entire thing where x was. So that would be a times c minus b all over a plus b equals c. When you go to check this, you could do this one of two ways. You could multiply the a to everything up here and then separate the fraction out and then simplify it. Or know that this would be the reciprocal of this denominator and these are just going to cancel. Negative b and b would just cancel. We're left with just c equals c, and that works. Do you have any questions on that one? These are basically the same, except one's being solved for x, one's being solved for y, so we're just going to do one of them. These have numbers in them, but because we have those two variables and we don't know what either of the variables are, it's still just going to be a literal equation. You won't get an actual answer. But for example 5, if I was trying to get x by itself, what would be the first step? Divide by 3. So in this case, that kind of works. If I were to divide by 3, what's going to happen is I need to divide everything by 3. So our property of equality will work. Let me actually write this separately. I am still dividing both of these by 3, but I'm writing it separately. This would give me x minus 2y. If you divide everything by 3, you end up with that ugly fraction of 17 over 3 at the end. But still we need to do something to get rid of the 2y, the negative 2y. So that's not an incorrect way to do it. That is one way to do it, yes. There is another way as well. But we're still kind of at that same step. How would we get x by itself here? It like helped us in a way because x is by itself, it doesn't have a coefficient except for 1, but it's still surrounded by things, by other terms. It's not completely by itself. Say that one more time. Divide the. So if I divide this by 2, I have to divide everything by negative 2. Would that help me get x by itself? Would help me get y by itself, kind of. But would that help with the x situation? Not really. That would actually make it worse. Then we'd have another number in front of x. Any other? Instead of thinking about this term as two separate things, as negative 2 and y. Think about it as one whole term, negative 2y. Do I need negative 2y at all to be with x?
No.
No. So I can get rid of the entire term altogether. So this entire term is getting subtracted from x. So I could add this entire term to the other side and get rid of it. I am going to check this here in 1 second. I'm going to go back to the original to show how you could have gotten this a different way. Let's not use that. If you had thought about that or that came to mind at the beginning, you could have started off with that, moving the 6y to the other side. And then dividing by 3. So this way is basically the opposite of how Kobe started this, and that's okay. Because they are the same in the end. So this way is 17 plus 6y all over 3. I could break this up so it's a little bit more simplified. So it's 17 over 3 and 6y over 3. But that would just give me this. They are the same, even though they look different. So whether you left it like this, not like this, because this can be simplified, so this or this, either one of those would work. Both of them will work when you check it. I'm not going to put both in to check it. I'm just going to put this one in. I believe on my filled-in notes, both ways are there. I'm not 100% on that. So to check this, I'm going to put this entire thing into the original equation.
Yeah.
I would say it matters to an extent of what is it asking you to solve for. So I would say if it is asking to get x by itself and you solve for y and end up with y by itself, you haven't done what they asked. So you basically have to go back and rework that. This would just leave 17 plus 6y. And then these would cancel, leaving 17 equals 17, which I know could be a true statement because 17 equals 17. It is the same number. Do we have any questions on that one? Sometimes you may be wanting to get like every variable without coefficients, but you don't need to unless you're solving for that specific variable. So I think that's kind of what, and that's kind of what you were thinking here when you divided everything by 3. You're trying to get that number away from it. Seven and 8 are very similar to 5 and 6, but these are all variables, no numbers at all. So we're going to try example 8. And we need to solve 8 for a. How would we start that? I didn't hear what you said, I'm sorry. Divide by what? So if we started, and I'm going to go back and say this, the reason why dividing everything by 3 works here is because 3 divided by 3 is just 1, it's something simple, and it made it disappear. 6 is divisible by 3, 17 wasn't, but that was okay. If these numbers were not divisible by 3, you would end up with fractions all over the place. I have no idea what A, B, C, D, and G are. If I start dividing everything by A, it's going to look like this. It would be B, not A, but it's going to look way more complicated than we really want it to. How else could we start that one? On this side.
Yeah. On that side, CD.
If I get rid of CD, that's getting rid of this term that I don't need. It's just kind of there, it's in the way. These aren't like terms, so I can't combine them, but I'm just going to move it to the other side. Then what?
Divided by D.
Divide everything by D, which is what I meant to do when I started this, but we have some fraction A equals G minus CD all over B. I have no idea what any of those are, but I know A is by itself. If I were to put this back into the original equation, that's G minus CD all over B times B plus CD equals B. Those B's would cancel. The CDs would cancel, leaving just G plus 0. That would work. Now, the way she guys started this, if I would have divided everything by B, that's not an incorrect way to solve it. It may have just given you more problems than you actually wanted. While you guys are working, I'll show what that looks like so you can decide on if that's a way you wanted to do that or not. You guys have questions about this one? For the remainder of class, you guys have a few different things that you can be working on. You can go back and do the other examples on this page if you so choose. There is a practice page. You can work through those. On the back of that, there is it says homework practice. It's not homework, but it is additional practice. Once you do some of these, if you feel good about them, you do have one Delta Math that I don't see you on Thursday, but it's due on Thursday. You have extra time to get it done. For literal equations. You also have 2 Khan Academy that are not on this, but are on the solving multi-step equations that are due Thursday. Remember, those are usually due Friday, but we don't have school Friday. So the Delta Math and those 2. And I also wanted to mention one other thing. Thursday, you guys are going to be taking your quiz for these two objectives: solving multi-step equations and solving literal equations. I'll explain it more on Thursday, but it'll be like a review quiz day. To mean not when we come back. Sometime after that is the test is coming. Just look at your course calendar to see what date that is. I don't know off the top of my head, but just know that it's also in Canvas. So make sure you're checking those dates. But you have the rest of this time to work on any of that stuff. If you have any questions, let one of us know and we'll be around to help you with that.
Yeah, I just want to say, on these number or letters are fun for you, they're not fun to me. Just throw a number on, so P is pretend it's 5. Put any number you want on I. It can't be the same if it's right, because the variables are different. Just put a number in. 3, 2, 5. Or no, it can't be 5. There we go. Okay, so what you've got is P equals, so these are, so I'm just trying to solve it for 7. So I want 7 to equal something.
I was going to say, that works if the numbers are different, yes, and you still use your inverse operations. Sometimes that also doesn't work because you get an actual number. I would say,
It would be the right.
yeah, like this one's kind of easier because it has some numbers, but like when it's all letters, it becomes a little difficult. But maybe replace 1 as a number and then try moving it around and see if that makes it a little easier if you're struggling with that. So this is, if anyone was curious if this would work, you don't need to pay attention to this. I'm just gonna do it because it's up here. A different one.